Hi, I have no idea what Juan Pablo just said, so hope it was okay. uh, I'm Mariko, that's my Twitter handle. I'm from Brooklyn, New York. Really excited to be here. And for this slide, if you're in the back and you couldn't really see, or if you want to follow along, reading the speaker notes while you go around, you can look up my Twitter, and I just tweeted the link to the slide. And the version that's on the Twitter should come with my speaker notes that I'll be saying. So if you need that help, I usually need this. I'm an English as a second language too. And I want to talk about that a little bit today. So, title of the talk is How to Be a Compiler. Before going to the compiler, I want to talk about language. So as I mentioned, I'm English as a second language learner, I guess. I'm Japanese originally. So in Japan, if you go to public school, you start learning English at grade 7, so 12, 13. And this, I don't know how it is in Spanish country or in Colombia, but this is a pen, this useless English sentence is essentially almost every English textbook in Japan use this as the first sentence that middle schoolers learn to English. This does nothing, like you never use this. But everybody knows this sentence, this is a pen. Like, okay, like this is a pen. So when I first started learning this is a pen was a fun way to introduction to English. Like it was very simple, it was very short, and I can just swap it with like a pen to cat to dog, and like feels like you speaking English. And now like you change the this to it, and like she and her and him, and like it was so much fun. But then you go into study more and then advance the course, you get to things like this. So this is actually what I took from a English textbook support. So this is like something that a textbook company handed to teachers so that they can create a curriculum. And basically you were given, maybe this is like third year into learning English, given this like long piece of English sentence. And then they will ask you what the boycott is about, or this small act, what does that point to? The funniest thing I thought was this question here. I don't know if you can see it, but it says, who is Barack Obama? So by the time I got to this, I was completely lost. Like I started out having fun with English, but then things moved really quickly. And I had to learn whole sentence structure, how to read the context, how to like see the reference. If they say they, then which one is the they in front of the sentence? I was completely lost, and I became really bad at it. In fact, when I started learning English, I was like really excited. I even took like extracurricular to learn more English. But then like by the time of like 6 years of learning English, I was just like, I'm done. And it was so bad that I got super low score on college graduation, high school graduation, college entrance exam. And I did not get any acceptance from any Japanese university that I applied because my English score was so low. So this is me in 2004. I'm like, man, English sucks. Like, I had this whole plan of learning about communications. I want to learn about journalism. I want to go into internet business. And English is just like not letting me do it. So I'm like, I need to fix this problem. So I did. I went into a English as a second language program in a university that had a campus in Tokyo. That was American University. I studied it for 6 months. I got a decent score. I was never this fluent yet. But I got a decent score to be enrolled in undergrad. So, in 2004, I was also like, it's kind of okay. It's, it's fine. So what I realized when I was struggling, because in this 6 months, only thing I did was English. I did not study. I graduated high school. Only thing I did was learning English every month, and in the hope that sometime I can get the score so I can start learning things that I wanted to learn. So I was like, man, I need to get this done. And then I realized that I don't really like cope with those, like, just have a conversation with native speakers and you'll get there eventually, or like just watch Netflix all over and over again and you get there. I tried that. I watched entire seasons of Friends and Sex and the Cities. Like I did that. Like, no. So I realized that the way I learn is to just deconstruct a structure. So this is a picture of me currently learning a Rust programming language. And I printed out a introduction documentation from Rust and kind of like draw it over and like annotating things like, if there's an exclamation mark, that means something, or kind of deconstructing the sentence to understand what's happening. Because to me, still, reading English is like a little like a difficult, like speaking like a lot easier. But to me, I still have to follow by finger saying like, okay, so this is saying that, so I need to go back that. So like drawing the line on the text works really good for me. And reminded me and became a base of this talk that I did this when I was studying in English. This is recent one, but in Japan, when you learn English, there's like, they teach you methods and there's like different school of method, and like they claim to like have like every English sentence can be categorized in 5 different things, and you can draw the line and you understand everything. So I took one of those methods, and what I did was I have a textbook and then draw a line under saying like, okay, this is the subject, so it has to be followed by verb. Oh, there's a verb. There's an adjective, that means it has to be followed by object, and I basically kind of like apply a syntactic grammar and draw it over to understand what English is saying, because I could never just like hear it and then understand. I had to kind of like compress myself and then understand what's happening. So recently, I think this was like 8 months ago or something, I had a huge problem with understanding buffer in Node. And buffer in Node is awful, by the way. It's awful. On top of that, the documentation for that is not so great. It improved recently. It got changed. However, before that, it was just completely not even understandable to me as in English. And I was like, is this my problem of not understanding English, or is this like super technical that I'm not getting? Like, which one of that? So I actually did the same thing that I did in middle school of underlining those. Anyway, so that's my learning English talk. So when you do that, you notice like these things bothers me. So like I'm loving it. Like love doesn't have continuation state. Like love doesn't take ing at the end. It should say I love it. Like I'm loving it is like completely illegal grammar. So if you pass this sentence to JavaScript or browser, then it would say like, same error as like, let's say undefined is not a function or something. It was like, meh. Like error. So like those grammars and syntactic learning doesn't work 100%, but it got me somewhere and it was really interesting. So move along decades. Last year, around this time, I had this project to make a programming language for myself. A little background, I was hacking on my knitting machine, which is a thing in 80s that you can send a program to and you can knit whatever the pattern or whatever the cat image that you want as a blanket. I already figured that out, the hardware part, and I wanted to do something on the software side. So in knitting, if you hand knit ever, especially in American knitting instruction, it comes like code. There's a lot of variables, there's a lot of repeats, and it reads like a code. So I was like, this is code that I basically just like, think about how to run it and then like execute it on my hand. Why don't I just do that on my computer? Can I make a software that understands knitting speak into a computer software so that I can design a pattern? So this is a little project, and this is an interactive demo that I made. So I can change the variable to change the completely different patterns by just like one variable change, and create a swatch here to make entire knitting pattern. You get the idea. So in order to do this, I was like, language to language, like I do that all the time, like think in Japanese and, translate in English, or like think in English and translate in Japanese, like should be fun. But then I was told you have to make a compiler. And my image of compiler was this. I was like, the compiler is a tiny box that lives in my computer, or like, I guess I install it in my computer and then just like a sad bits of code went through there, and if they're happy, they come out. If they're sad, they're just stuck there forever. It's just like something that I don't really understand, and then something I thought, that's somebody's job. That's, I make websites, not my job. But I was told I need to make a compiler, and I, did it. So once I did that, it was like super fun, and I made a project out of it. So I wanted to share how much fun and how, I didn't necessarily say easy, but how simple to get started with compilers. So today, we're going to learn, right this minute, a new programming language called Design by Numbers by John Maeda. It is a book and the source code published in 2001 by MIT Media Lab. This is a programming language that's designed to teach somebody who is not a programmer or who is an artist, teach them about computer programming concepts by visual way. So the code for Design by Numbers looks like this. So this is the first example that comes up in the book, and this is the simplest form of this DBN. So paper means have a paper, and then paper takes one argument that is a color code. In this case, it's 0 is white. There is a pen, then it also takes a color code, in this case, black. And then you go into line, and if you do like SVG and stuff, you can just kind of guess it. The first 2 is XY coordinates for the starting point, and then last 2 is the XY coordinates for the ending point. So simple, seems simple. Can we try it? So this code, which one of the picture do you think this code will produce? Top or bottom? Who think it's top? Who think it's bottom? Like, you can raise the hand. Yay! Congratulations, you just became a compiler. You just did. Compiler is essentially just a piece of a function that takes some kind of input as a code input and produce something else. So in your brain, you just took a piece of text, turned it into thinking what would the graphic would be, and then just produced a graphic, and you became a compiler. So let's look at what just happened in your brain, because in the brain, it's so easy that like it happens in the speed of light, but let's just like go step by through in what would compiler brain do. So first, you see these texts. And in these texts, you separate it into each keywords. Now, you might say, it's easy, like the keywords are all separated by white space. It's true in English case most of the time, and I think in Spanish too. But in Japanese, in my case, some of the sentence doesn't have a space in between for words, and it's really confusing for somebody who's learning Japanese to see which word and where it separates. So even separating a word and identifying each single piece is a task. Once you identify the piece, you can go ahead and think about, is it a word or is it a number? Because in this programming language paradigm, there's always one command and then a numbers. So you can decorate that as, okay, for orange, it's a word, and then for yellow, it's a number. And in compiler speak, it's a lexical analysis or tokenize. And then once you do that, you go through that token again and think about what's the structure of this sentence. We agreed on the grammar that certain commands take certain amount of arguments. So now we can group those together. Before that, it was completely separate individual and you didn't know. So you think about, okay, paper and 0 are together, pen and 100 is together, and line and other whole numbers are together. And you create a syntax tree of what's happening in this document. Next step that happens is called transform. Now, you have to change this Bravo text into a picture. As a compiler, you need to do those steps. So you translate it to something that you can act on. So in this case, we translate it to human readable language. So the paper 0 becomes get white paper because 0 is white. Pen 100 becomes grab blank pen because 100 is black. And then a line becomes draw a line in the middle from left side to the right side. So you can kind of annotate this code by where those numbers were and where those commands went. But we just translated it into sorry, not Japanese, it's Japanese to me, but human understandable language. And the last step of it is called code generation, the actual production of something that you want. And this is me code generating. It's a wrong color and wrong pen. But I select the color of the paper, select the color of the pen, and then I just like find a starting point and end point, and then draw the line. And that's what you would do if you had a piece of paper and pen instead of sitting in the conference room and looking at the screen. So those are the steps for compilers. I thought this was quite interesting. This programming language designed by Numbers was made in 2001, and it was in Java. I couldn't even learn it. I don't know how. So I was like, oh, this should be really good with SVG, because SVG itself is just one element, like lines and rectangles. So I started converting design by Numbers that was done in Java into a small programming environment that you code and then produce SVG. So we just went through how to think like a compiler, but let's look one more down on how to produce the data for compiler if you are actually making compiler. So the first step I mentioned is lexical analyzer or tokenize stuff. So you take the word, you split it by white space in this case, and then you check, is this word none? I literally call is none. And if it's none is always confusing me. Oh man, if it's not a number, that means word. Yes, is none true is not a word, and is none false is, yes, is none false is number. Sorry, I have to do this conversion in my head. So that happens. And then this object gets passed to another system called a parser that creates what's called abstract syntax tree. And I just call it, it's like fancy speaks for finding out structure of the text, I guess. So I convert those each tokens into something that is more by blocks and nested. So in this case, I have a call expression paper. And before that, I had another element that's on the same level, the number. But I can nest those numbers because call expression paper and 100 argument is the same thing in this syntax. So I started making this thing called abstract syntax tree. Next step is transformation or transformer. So in this case, before that, we converted into human readable language. But to me, this time I have to produce SVG. So let's create it something suitable for SVG. Because there is no paper element in SVG. There is no pen attributes in SVG. So if I were to make a paper out of SVG, then I would probably use rectangle element. So I convert that to rectangle. And rectangle element takes specific arguments, so I find out what it should be by looking at the attributes that came from the previous version. Once I have that, then I already have a map to make a SVG out of it. And this is a code generation step. And in this case, I literally string replace this lect and SVG and everything, and string replace attributes in there to produce SVG and then put it into the body. So here is a interactive demo environment that I made. So let's see, I can change the color of the paper by 50. It's halfway through, so it's gray. Color of the pen to 100. I can add line. It's hard to do it in my one hand, but let's say it starts by 0, 0, and 100, 100. Oh, by the way, in this programming language, a paper is always 100 by 100. It doesn't say pixel, but it always 100 by 100. So, you can start drawing. And I created a demo for what's actually happening when you type each letters. So here you can see when you change something, everything changes. And this is the state that we just looked at. So, tokenization, making an AST, and then transforming into abstract syntax tree that is understandable to SVG, and then generating a code. So if you're interested in it, I have a link to it after this slide. You can just go ahead and play around and see what's happening inside. So hopefully, this explanation gave you like, this scary thing called a compiler that I don't really understand and made it into something that's like a box of fun. Like it's fine that it's still like kind of confusing because, once you started learning about compiler, you have to do a recursion and traversal and then like something called like visitor, which I don't even understand. But you don't have to know those things to start making compilers. Those are great technologies and great method to make like fine compilers, but you don't really need those to start doing it. And once you get rid of that confusing part, then like what's left to me feels very fun. So much fun that I have an idea. How about making a JavaScript that's entirely in Spanish? Like, I don't know. I always struggle with switching keyboards between Japanese and English and like, I was typing in Japanese and now like I type function, it's like total like, nonsense come out. You can totally do that. You can make your own compiler to compile it into a regular JavaScript. In fact, there is somebody who already made those, not for Spanish though. There's a Fika script. Fika is in Swedish called a coffee, and Swedish love coffee. So there was somebody who made a JavaScript transpiler to type it in Swedish and then convert it into English, or English to Swedish. Kind of fun, and it's possible, so should be able to do it with Spanish too. Another one, emoji code. You can code with emoji. There's like pizza one. I couldn't really find the link, but I saw one project that was only used pizza emoji to make a data visualization, I think. So like 1 pi is 1 unit, and then like you kind of combine it to make something. It was fun, super fun. You don't have to deal with text either. Like we produced image out of this compiler. The input can be image too, and there is a Piet. So I took idea from Piet Mondrian that the input for or code for this compiler is a colored pictures. And here's an example of what the hello world would look like, what the Fibonacci sequence would look like, Tower of Hanoi look like. It's super fun. So I hope you make one because it's a lot of fun. But I strongly suggest try making tiny one because it taught me a lot about software development. It was really fun to make my own language itself, but the process of it was so much valuable than what came out. And I want to share a few things that I learned while I was doing it. First of all, just start like a lexical analyzer. Like it's okay you don't understand something. Like when you're dealing with like a new library or new way of doing things like Virtual DOM and React and you don't really understand, it's okay, you will eventually get there. You have to deal with it later, but you don't have to be overwhelmed and have to think that like, I have to figure out everything right now. You can just pass it on as like, okay, React is a new library, okay, I'll figure it out later, and then eventually in the parsing stage, you will understand what that does. But it's okay to have unfamiliar things, and just like, be like lexical analyzer, just like, okay, here's this thing, move on, Another one is be a good parser. So here's the thing. We get frustrated by undefined is not a function. It gets a lot more frustrating when you make your own programming language and your own error message doesn't make sense. So I had one error message that says unknown token or something. When I encounter certain words that's not supposed to be there, I would say unknown token. When I was writing a code, it felt like it's perfect error message. When I was debugging it, it did not make any sense. The error code did not give me any idea of what was wrong or what was expected. And, it's really practical when we were dealing with programming, not only writing error messages, but being helpful to somebody else. Like if somebody is stuck on the process, I'm like started out 2 or 3 years ago, so I'm like still junior and then like have a lot of questions. When I have questions, it's a lot helpful when somebody says, I would Google this and that, or why don't you look at that page of this documentation, other than, oh yeah, that doesn't work, right? You can add a little bit. You don't have to do work for them, but you can just add a little bit of helpful information so that they can get there faster. Elm language is a language that embraces that. Elm has this thing called compiler errors for humans. And when they throw an error, they give you did you mean? Basically like a Google's what did you mean? So they suggest you where to look for solutions, suggest you the new methods to call for. Elm is trying to build those friendly, helpful error messages. And the last one, and especially I think important for such a diverse audience and diverse background of people, is that bridge the gap like transformer. Context is everything. There is no single way to do something right. Once you took user experience in the United States into user experience in Colombia, it's completely different. And somebody needs to translate that why it's different. And just, be a good transformer. First, if you think you are not good transformer, you can think always that there's always a context. I should think about other contexts. There is my context is not always true. If you know a good transformer on your team, somebody who's really good at bridging those gaps, then just embrace them and just be thankful to them because they add so much value to your project, even though they are probably not producing the code, but they add a tremendous amount of value to produce a good code. Context is everything. So at the end, I'm just thinking that compilers rules, and it's super fun, and it's fun to make one. It's great to be one. Act like a compiler, act like a great team member, and I hope you have fun. So I have a little compile challenge. I load up a piece of code. If you want to be a human compiler and draw it on the piece of paper, and if you do that, I have a prize for you. But you can also copy and paste and put it into the online demo I made and see what it is. If you do, find me later today, and I really have a prize for you. So the link for the online demo is github.io/sbn, and the code here is posted on the Bitly link compiler change. My Twitter handle is Kosamari again. If you have any questions, comments, concerns, anything, please tweet at me or DM me. Thank you very much.